Hi all. Today I am going to explain you about divide and conquer method in design and analysis of algorithms. So first I'll explain what is meant by divide and conquer method. Okay. First we'll be seeing an example. What is meant by divide and conquer? Okay. So nothing but if we are taking a problem. Okay. If we are taking a main problem, here what we are going to do is we are going to divide a problem into subproblems. We are going to divide a problem into subproblems. So when we are going to take a large problem, in order to solve that large problem, it is very difficult. So at a time we can't solve that complete problem. So what we are doing in divide and conquer method, we are dividing the main problem into subproblems. Okay. And after dividing a problem into subproblems, we are finding the solution for each subproblem. We are finding the solution for each subproblem individually. Okay. We are finding the solution for each problem individually, and at last what we are doing, we are just combining the solutions of each subproblems into a final solution. So why we are using divide and conquer method is, in DA we have different algorithms. Okay, we have backtracking algorithm, divide and conquer algorithm, and different type of methods we have in order to solve the problems. Okay, so the first method is divide and conquer. This general example we can consider when we are going to 10 acres of land, 10 acres of farmland. So when we consider this, 10 acres of farmland can't be farmed by an individual person. So the work is divided among the different people who are going to work for that farmland, and for each farmland, like for example here we are taking 10 acres of land. So this 10 acres can be divided into each 10 parts. Nothing but each person will be getting 1 acre of land. So for each person we are dividing it into 1 acre. When we are dividing all this, now how many persons are going to work here? 10 persons. Okay, 10 persons are going to work here. Now each person will farm that particular 1 acre of land, and he will get the final output. In the same way, when we are going to take a big problem, in order to solve that problem, it is difficult for a person to complete that particular task. So we are dividing the problem into subproblems, and for each subproblem we are getting the individual solution. Okay, and finally what we are doing, we are combining the solution. So the final problem for which we are taking the initial problem, we are getting the solution. Okay, this is nothing but divide and conquer. So under this divide and conquer, we have two algorithms. One is quicksort, and the second one is merge sort. So under this divide and conquer algorithm, we have two algorithms, nothing but two methods where we are using divide and conquer method, and we are solving this. One is quicksort and another one is merge sort. Okay, now we will be seeing about quicksort. So why divide and conquer method name is there is nothing but we are dividing the problem into subproblems, and we are conquering the individual problem solution, and at last we are combining it. Okay, next we'll come to quicksort. Algorithm. So what is meant by quicksort algorithm? Nothing but by using divide and conquer method, we are going to arrange an array into a sorted array. Okay, so for example, here we have two algorithms. One is partition algorithm. One is partition algorithm and the second one is quicksort. So here, in order to solve the array using quicksort, we have two main in that algorithm we have two main parts. One is partition algorithm and the second one is quicksort. So now I am going to explain you what is partition algorithm. Okay, so I'll be explaining you this partition algorithm, how we are using in order to arrange the array in a sorted order. I'll take an example. With an example, I am going to explain each and every step. So I am taking an example here. 7, 6, 10, 5, 9, 2, 1, 15 and 7. So what I am doing here, I am taking an array. Okay, when we are looking it into an array, this array is not in a sorted way. Sorted is nothing but not in ascending order, either not in descending order. So we are going to solve it. First, what we are going to do is, in quicksort algorithm, how we are going to do is, first we are using partition algorithm. Okay, with the help of this partition algorithm, I already said how we are using divide and conquer method. Divide and conquer method is nothing but we are dividing the problem into subproblems, and each subproblem we are getting the solution individually, and at last we are combining it together, then we are getting the final solution. Okay, so randomly we took few numbers. This is an array. Okay, in order to perform the algorithm, we need to make this sort array into a sorted way. Okay, so I will be explaining you the partition, what is meant by partition algorithm, then we can know into deeper in it. Okay, so what is meant by partition algorithm is nothing but with the help of pivot. Okay, with the help of pivot value, we are going to make the changes in the array. So when we are going to consider the value of pivot, what we are going to do is, if the pivot element position is fixed, then the left side elements to the pivot element will be less than this, and the right side elements to that pivot element, it will be greater. Okay, so in order to find the perfect position for pivot value, we are performing the partition algorithm. Okay, I'll be writing the code here first. So what we are going to do is, we are initializing the I value. Okay, so this is an array. When we are taking an array, we need to give the index values. Okay, we need to give the index values. So always the index value will be starting from 0, 1, 2, 3, 4, 5, 6, 7 and 8. So the array value will be starting from 0, but the last element is 8. So what is the n value here? N value will be 9. Okay, the total number of elements in the array is 9. So n value is 9. Now what we are doing is, we are initializing I is equals to 0 and j equals to n minus 1. Okay, I value will be 0 and j value will be n minus 1. So what is I value is equals to 0 means nothing but we are initializing I value to 7. Okay, we are initializing I value to 7. I value to 7. Now what I'll do, I will initialize I equals to 0, and what is j value? J is initialized to n minus 1. Okay, now I value is initialized and j value is also initialized. Now what we will be doing? We will be doing like, we need to initialize pivot value. pivot value is initialized to 7. Okay, so what is the a value here? What is the a value? Array of a I. What is the array value here? What is I is 0, right? So what is the value in that array? 7. So this will be the pivot value. Okay, what is the pivot value here? 7. And what is the array of I? 7. Okay, so what is the j value? J value is 8, right? So what is partition algorithm? Now I will write the code here. If I value is, if I value is less than or equals to j, what we are going to do? We are comparing array of I value is less than or equals to pivot. You are incrementing I value. Okay, I'll explain. Next, if array of j value is greater than pivot, what we are doing? Decrement the j value. Okay, next, if these both conditions are not satisfied, what we are doing? Swap a of I comma a of j. Okay, so in detail we will be going to see here. It is clear, right? I value is initialized to 7, pivot value is also 7. Next, what is the j value here? 8. Okay, now what is the condition? First condition here, I value is less than or equals to j. What is the I value? 0. 0 is less than or equals to 8. It's true. So what is the next step? A of I is less than or equals to pivot. So what is array of I? 7, right? Now 7 is less than or equals to 7. True, right? What we need to do? We need to increment the I value. So what I'll do? I'll be incrementing the I value as 7 is less than or equals to 7. So I am moving the position of I to 6. Okay, now what is the next step? Same procedure. Why? Because A of I is less than or equals to pivot. 6 is less than or equals to pivot. 6 is less than or equals to 7. So I'll be in this place. So what is the next step? I am incrementing the I value. Okay, so what is the thing here is, we are checking array of I value is less than or equals to pivot. If array of I is less than or equals to pivot, we are incrementing the I value. Okay, so now when we are coming to 10, array of I, a of 2, nothing but the value is 10. 10 is less than or equals to 7. False. The condition fails here. Now what is the next step? If the condition fails here, what is the next step? Array of j is greater than or greater than pivot. Will be coming from the right end. Okay, now what is array of j? 7. 7 is greater than 7. No, it is false. So when this two condition fails, what we are going to do? We are just swapping array of I comma array of j. Nothing but we are changing the values in array of 2 comma array of 8. So what will be the next array? The positions will be 7. New array will be 7, 6 and 7, 5, 9, 2, 1, 15 and 10. This is the new array. Why? We swapped these two values. The values in index number 2 and the values in index number 8, nothing but 10 and 7. We swapped these values. Why? The value which is in j is not greater than pivot, and here the value which is there in I is not less than or equals to pivot. So when these two conditions not satisfying, what we are doing, we are swapping the values which are there in that particular index. Okay, so now the new array will be like this. Okay, the new array will be like this. Next, where we are here, like the I position is in index number 2 and the pivot is 7. Okay, and the j value is near the position 8. Okay, this is 0, 1, 2, 3, 4, 6, 7. Okay, what is the next step again? When we what is the next step? The array of I, nothing but 7 is less than or equals to 7, true. So what we will be doing, we are incrementing I value. Okay, next 5 is less than or equals to 7. Okay, 5 is less than or equals to 7, it is true, increment I value. Okay, next 9 is not less than or equals to pivot. No, so what we will be doing, we will be stopping the here, we will be going to j. So 10 is greater than 7, true, decrement j value. So j position is near 7. Okay, so 15 is greater than 7, true, 15 is greater than 7, true. Next 1 is not greater than 7. Okay, so both the position near I and j is same, both are not satisfying the condition. What is the next step? We need to swap these two values. Okay, then what will be the next array? 7, 6, 7, 5. We are interchanging these two values, 1, 2, 9, 15 and 10. The new array will be looking like this. Okay, so what is the next thing? What is the next thing? Where is the I position here? I position is near index number 6 and j position is here, index number 6, and I position is near 1. Right, now again what is the next procedure? I value, nothing but 4 is less than or equals to 6. So what we are going to do, array of I, nothing but this value, 1 is less than or equals to pivot. Okay, so increment I value. Okay, next j, 9 is greater than or equal 9 is greater than pivot, so decrement j. So both, 1 minute. Now when we are seeing here, I value is here, right, near index number 5. So what we are going to do is, when we are seeing here, so 2 is nothing but 2 is less than or equals to 7. So we will be incrementing the I value here. J position is here near 9. Okay, j position is near 9. J position is near 9. So until here it is satisfying the condition that a of I is less than or equals to pivot. So we are incrementing the I value and we came till 2. 2 value is also less than or equals to 7. So we are incrementing the I value here. What is the 9? Next to number 9. So when we are seeing here, 9 is not less than or equals to 7. So the I place will be pointing to 9. Nothing but the index number is 6. Okay, so next, what is the j value here? We'll change the color so that you will be understanding. What is the j value here? J is pointing to 9. So what is the next thing? J greater than pivot. Okay, nothing but array of j is greater than pivot, it is true. So what is the next step we are going to do? Nothing but j minus minus, right? So j is pointing to index number 5. I'll be writing here j is pointing to index number 5. Okay, I is pointing to index number 6. Okay, what is the value in index number 5? Nothing but a of 5 is equals to 2 and a of 6 is equals to 9. So now this value came to 2. Okay, j is pointing to 2 and I is pointing to index number 6. So what is our initial condition here? When I value is less than or equals to j, only we are going to do this operation. Okay, when I value is not less than or equals to j, what is the next step is when I value is greater than j. When I value is greater than j, what we are going to do is swap array of j comma pivot. Array of j comma pivot. Okay, this is nothing but whenever the value of I is less than or equals to j, we are going to check whether the array of that value, the value in that particular index is less than or equals to pivot. Then we are incrementing the I value. If array of j is greater than pivot, we are decrementing the j value. In case this both conditions are not satisfying, we are swapping both the values in that particular array. Now if I is greater than j, what we are going to do? Swap a of j comma pivot. So it exceeded, right? I value came to 6, j value came to 5. Now I value is not less than or equals to j, right? 5 is not less than or 6 is not less than or equals to 5. So what is the condition? Now array of j is pointing to position 5. Okay, so we will be swapping these two values. We will be swapping the two values. Now what will be our new array? These two values we are swapping. Okay, so 2, 6, 7, 5, 1, 7, 9, 15 and 10. So this will be our new array. Okay, we are fixing the position for pivot element. What is the pivot element here? 7, right? What is the position of that element? 1, 0, 1, 2, 3, 4, 5, 6, 7 and 8. This is the pivot element. So initially I have said that we are fixing a position for pivot element. The elements which are left to that pivot element will be less than the element, and the elements which are placed right side the pivot element will be greater than that pivot element. Okay, so when we are seeing here, all the elements which are left side, those are less than or equals to 7, and these values 9, 15, 10 are greater than this pivot element. See here, nothing but we are using that partition algorithm in order to place, like in order to fix the position per pivot element. We are using this partition algorithm and we are fixing that array. Nothing but we made it into some sort of sorting order. Not at all done completely. We know we have two sortings, nothing but ascending order, in ascending order or in descending order. So we need to place them either in this way or in descending order. So once again I am going in a brief. we are using partition algorithm in order to find out the quicksort. We are maintaining like we are using the partition algorithm. Partition algorithm is nothing but we are fixing that we are initializing the I value and j value. Okay, I will be initialized to 0 and j will be n minus 1. Okay, and what we are doing next thing, if I value is less than or equals to j, what we are doing here, we are comparing whether if that value is less than or equals to pivot, we are incrementing the I value. If not greater than pivot, we are decrementing the j value. If these two conditions are not satisfied, what we are doing, we are swapping I and j value. Okay, next, when this I is less than or equals to j, we will be doing this. If I is greater than j, what we are going to do, we are going to swap pivot value and array of j. Okay, so by doing this partition algorithm, we made this final array. Okay, we got this final array. So now we will be using quicksort algorithm in order to arrange them in ascending order. Okay, now I will write code for quicksort algorithm. So what is here, a is nothing but the array and I and j. Okay, we are considering 3 here. One is nothing but the array and initialized values nothing but I and j. Okay, next we are writing, we are finding for partition algorithm, we are calling, okay, partition algorithm with the help of array and I value and j value. Here location is nothing but we are with this location nothing but the pivot element location we are fixing here. Okay, so this is the quicksort algorithm. Okay, already we have seen here partition algorithm. This is the partition algorithm, array I j. Okay, this is the partition algorithm. If this value is not there, like I is greater than j, what we are doing, swap array of j comma pivot. Okay, this is the partition algorithm and this is the quicksort algorithm. What we are doing here, now we had find the location is nothing but the pivot element position. Okay, now what we will be doing, now with the help of this pivot element position, we are going to divide the array into 2 parts. So what is the concept here, quicksort algorithm, which method we are going to use here, divide and conquer method. What is meant by divide and conquer method? Divide and conquer method is nothing but we are dividing a problem into subproblems and we are finding the solution for individual problem and we are getting the solutions Finally we are combining the solutions of each individual subproblem, right? So here, in order to sort this array, what we are going to do, we are dividing the array into two parts with help of pivot element. Okay, with the help of pivot element. Pivot element position is fixed, right? With the location variable, we are going to divide the array into two parts. Okay, so now what will be the new array? The divided array will be 2, 6, 7, 5 and 1. We are not considering 7 here. 7 nothing but the pivot element value we are not considering. Why? Why? Because the position of that particular element is already fixed. No need to insert in either left array or right array. Why? Because the position of that particular pivot element is fixed. Even if you are keeping and if you are trying to arrange again using partition algorithm also, the position of that particular element will be fixed. Okay, so we are not considering this element in either two arrays. Okay, so what is the left array? 2, 6, 7, 5, 1. Okay, what is the right array? 9, 15, 10. Now what is the next procedure? Same what we have done in order to make that array and fixed the position of pivot element by using partition algorithm. Same thing we are going to do here. Okay, the same procedure, nothing but the position of I. Okay, this is the position. Not like we are initializing it as pivot. Next we are initializing j value as 1. This the index numbers will be 0, 1, 2, 3, 4. Okay, what will be the right side array? 0, 1, 2. This will be I value, this will be pivot value, and this will be j value. Okay, here nothing but we are fixing the pivot element position and we divided the array into two subparts, and we are we are going to sort this array into a ascending order or descending order, whatever the things we are going to do. So we are taking it into a sorted order. Okay, so again the same procedure. I value is initialized to 2 and the pivot value is also 2. So I is less than or equals to pivot, true. What we are going to do? Initializing, incrementing I. So when we are going to 6 is not less than or equals to 2. What will be doing? We will be going to j. 1 is greater than 2? No. So we are stopping this procedure here. What is the next step? We need to swap these two values. What will be the new array then? 2, 1, 7, 5 and 6. So the next new array will be like we are swapping the two values. Next it will be I, it will be pivot, it will be j. Okay, so where is the I value? Near 1, right? 1 is less than or equals to 2, true. Increment I. 7 is not less than or equals to 2. What will be doing? We'll be going to j. 6 is greater than 2, true. Decrement j. J is pointing to 5, right? 5 is greater than 2, true. 7 is greater than 2, true. So when we are crossing the I position here, 1 is, this comparison should be done when I value is less than or equals to j. But we are crossing the value of I and we are coming to j. Now the position of I is, near 2 and j is 1. So at this time what we are going to do is we are going to swap 1 and this pivot value. Okay, Now what will be the next array? What will be the next array? So a of j is 1 and the pivot value is 2. So we are going to interchange this. 1, 2, 7, 5, 6. We swapped these two values. Okay. The next array is 1, 2, 7, 5, 6. Okay. The same way what we are going to do for next array also we will be doing. Okay. What is array of I? 9. 9 is less than or equals to 9. True. Increment I. 15. 15 is less than or equals to 9. False. Next. 10 is greater than 9. True. J is pointing here. 15 is greater than 9. True. Next. J came to here. Okay. When 9 is greater than 9. False. Now what we are going to do? These two values we are going to interchange. Okay. What will be the new array then? 9, 10 and 15. Here what will be the new array? 1, 2, 7, 5, 6. The positions are not in sorted order. Again we need to do. So the final output will be getting 1, 2, 5, 6, 7, 7, 9, 10 and 15. This will be the final output for that particular array. What we are going to do? We are placing them in ascending order. Okay. By using partition algorithm and quicksort algorithm. Okay. Thank you. Pivot